So we're going to get going, and I'm sure people will trickle in as we move forward. Our session this afternoon is, let's see, where's our, well, we're about ownership, sharing, and innovation. And of course, that's a critically important topic for the future, not only of research, but also of this field as an industry. And I have to start by saying that, you know, my background is I'm from the microelectronics field. I lived and breathed Moore's Law for 30 years. And I've got to tell you that this feels a heck of a lot like microelectronics did 30 years ago. It's not biotechnology, what you guys are doing. It's much more like microelectronics. And in fact, it's interesting to note the kind of people making the investments in the startup companies that you're forming are often not the same people that invested in biotechnology, but a lot of them are the people that came out of the microelectronics community. They kind of get it. Now, back when we started this industry, we were talking about deep issues like should we build our chips on germanium substrates or silicon substrates or gallium arsenide substrates. And what's interesting is that gallium arsenide is theoretically better than silicon. And in fact, contrary to popular belief, MIT spent a long time trying to make gallium arsenide work before finally in the early 80s, 15 years after the rest of us, they suddenly realized the future was silicon and they switched and they started to work on silicon. Now, part of the reason that that happened was because they weren't as close to industry as we were here on the West Coast. And it was that integration of that feedback between industry and academia that really made us, kept us honest, if you like, relative to the practical implications as well as the ideal and theoretical implications of the technology. Well, you know, as I get it, you guys are trying to decide whether it's E. coli, bacillus, or yeast, sort of metaphorically speaking, or maybe something else, as your very well characterized substrate, and you're assembling your catalogs of parts to embed in those substrates that are very well characterized, very well modeled, to perform some function. You may not be building a MP3 player, you may be spinning silk to make pajamas, but the principle is ultimately the same, at least it seems to me. Back when we started, it was really important to us that the components of our technology were open and accessible to the entire community. It was absolutely critical. I can tell you as one who lived through it, from the EDA tools to the resistors, the capacitors, everything that went on there. We worked very hard to make that the case, while at the same time allowing the Intels of the world to build highly proprietary parts that were very well protected, that they could make lots of money off. And so that balance between components and systems, the community element as well as the proprietary element, is kind of what this discussion, at least I think, is about here today. Now, you know, I see these diagrams that this community floats around with devices and parts and substrates and test beds, and of course I put my spin on that relative to where we were back 30 years ago with respect to the same kinds of discussions. And it seems to me that there are two kinds of artifacts that we're dealing with here. One is the kind of artifact I call an artifact of discrete contribution. It's something that you can write a paper about and you can learn from that paper all you need to know about that thing. You can patent it, you can protect it, you can license it, and there's kind of a meaningful discussion to have around who owns it. The other kind of artifact is what I call artifacts of collaborative evolution. And these are the kinds of things that, well, the right answer kind of evolves over time. You've got to get it to be able to really understand what's going on. Usually a very low protection barrier is in existence before the community is built. A lot of the CAD tools, a lot of the methodology typically has been that way in my industry. And then you need to really be immersed in the community to get it and to understand what that particular contribution is all about. And then, by the way, by the time it actually is useful and important, everyone says it's obvious. It's another characteristic of that kind of contribution. But at the time, a lot of people just don't plain get it. The balance between these two kinds of artifacts is really important, and they're both equally important. And if I look at what's going on today, we've got companies and we've got universities and we've got research labs, and they're inventing various kinds of components and processes and methodologies. And of course, at first glance, the companies at least want to keep those proprietary and own them and protect them and manage them. There are also groups among us here, we've heard about some of them this morning and earlier this afternoon, that are interested in sharing these components and developing open and shared repositories for not only the components themselves, but all of the artifacts that are necessary and the knowledge that's necessary to go with them, whether it's the measurements or the CAD tools or the modeling and so on, the know-how, those artifacts of collaborative evolution that are really critical. And the argument we're making, right, is that if you're a company and you contribute your stuff to the repositories, you benefit by being able to share all of the knowledge that's accumulated by the community as a result of that contribution. And of course, that's also true for the universities and the research labs. One of the things that was incredibly important back in the microelectronics days, and Randy Retberg's here, Tom Knight's here, they were part of that phenomenon, was also the fact that because of this shared knowledge, places like universities had an opportunity to educate students, and they ended up going into the companies kind of fully aware. They had the vocabulary, they had the knowledge, they had the perception of what was going on that was actually more important even than the chemistry necessarily in the equivalent day. So what's the trade-off? On the one hand, I'm a company, I'm investing $100 million in the development of a new and exciting idea in synthetic biology, a new component, and I'm being asked to contribute that for free to this repository. Can I afford to do that? Will I do that? Why should I do that? Are there some things we could talk about that will allow us to give those companies or those inventors an advantage and a potential return on their investment early on, while at the same time encouraging them to enable this community and keep this industry going? And I think that's kind of the framing of the issue that we're dealing with here. So we have two quick presentations and then some discussions. Ken Oy spoke earlier. I'll let him introduce himself, and then Arti Rai is going to follow him, and then we'll have some discussion. So, Ken.
Okay, why don't we get started? This session is on ownership, sharing, and innovation. And the title that this talk has is Synthetic Economics. Now, given the synonyms for synthetic we heard earlier, I'm not sure. I think I would probably change the title. What I want to talk about are commons, enclosures, and anti-commons, but with explicit reference to the categories that Drew laid out in his presentation at the end of day one. If we look at several points here, Drew, you may recognize that little chart or diagram from Drew's talk on systems, devices, parts, and DNA. First part of this talk is going to be on what objects may be owned and or shared. And this includes the items on that slide, as well as representations of data on reliability and on failure, as well as technical standards and protocols. And we'll kind of go through those in a little bit of detail. But the issue is also under what arrangements. And we have a range of possibilities: patents, copyright, licenses, trademarks, public domain, and sui generis. And I'm going to start to raise some of these arrangements, but I'll leave the stories incomplete, because we have a lawyer sitting here who will come in and give you, let's call it, the final authority on each of these issues. Artie will pick up where this leaves off. And then we're going to turn to the issue of, well, look, we have these arrangements, we have these objects, with what effects on innovation? And so there's a little argument on commons and enclosures and how enclosure creates incentives to invest that we're all familiar with. And I'll weave that into the presentation. But at the same time, there's real danger here. And the real danger is that as enclosures take place, these semi-permeable and ambiguous thickets give rise to anti-commons problems where ambiguity and rent-seeking lead to underinvestment. Finally, I'm going to end with a little note on security and the expropriation of property rights that kind of links together this morning's session with some of the issues on property rights from this afternoon. So let me get started. Let's begin with the easy part. I think Dr. Ventnor is no longer here, but if we're talking about DNA and DNA fragments or ESTs without specification of useful functions, There's a little problem with making property rights claims on this, and we can all go back to the U.S. Patent and Trademark Office and its directives to examiners. Not mysterious, we all understand this point. Now, what makes life interesting here, when we turn to parts world, is that the parts that you're creating are in, well, you have a sequence, but you also have specifically defined functions. You also have the representation of data on interaction effects. You're trying to gather that data and put it into usable form. You're also presenting data on reliability as well as on interaction effects and compatibility. You're also investing a lot in refinement to produce standardized couplings. And finally, your database certainly includes a little bit on ownership. Information on ownership, meaning how is this stuff, are these parts protected? Is it through public domain, or are you talking patents, copyright for, you could be talking patents on the part, you could be talking potentially copyright on some of the representations of data. And the patents and copyrights might be licensed in ways that could create incentives for open source. We'll come to issues of trademark and sui generis a little bit later. But the point here is that the parts that you're creating or fabricating are certainly not DNA. And there are a range of components when you look to that fact sheet sitting there in the lower right. Okay, some of it is information on reliability presented in ways that could potentially present issues of protection, as well as, let's call it, the core patents on the devices, on the strands or parts themselves. Now, if we turn to systems and devices, we move up a level. I, of course, chose a patent that would be of interest to Jay sitting here on the front row. Okay, what we're talking about here, and I'm not quite sure exactly where to draw the line between parts and systems, but we're talking about the parts assembled as devices or machines or as organisms. The examples could range from oscillators to red light detection circuits to engineered microorganisms to produce isoprenoids with pathways specified. And that's what that patent covers. There's relatively little ambiguity in terms of, let's call it the law, in terms of whether this stuff is patentable. And in terms of what Rich was laying out, okay, we're talking here not so much about the components, but about the assemblies. And your view of how the field should evolve would say, by all means, assign protections at this level to create incentives to innovate. But let's try to keep the parts as open as possible. Now, life is a little bit more complicated, because if we turn to systems, still sticking with Drew's set of distinctions, system is sometimes used in ways that are not quite as specific as a yeast re-engineered with pathways to produce isoprenoids. You take this patent on molecular computing elements, gates, and flip-flops, and it is as much a design principle, and a broad one at that, as it is something that is, let's call it, narrowly defined and framed. Okay? Artie is going to be picking up on this. The issues that are raised by these broader patents in that category that could be called system, that could include so much. If we go back to that Scientific American article that everyone here has been handed and read a couple times today, overly restrictive licensing and smotheringly broad patent interpretations could make a shambles of synthetic biology. And the argument here potentially is that if patents are in fact broad, the boundaries unclear, the transaction costs associated with assembling bundles of rights on the one hand, and the simple cost of purchasing those rights, where it's hard to work around because of the breadth of the patent, potentially slows down this field. Now, there's another little component to the Scientific American article as well, and I'm going to go back to the Registry of Standard Biological Parts in Drew's world. If we go back to Drew's slide yesterday, I want to draw attention to the little green bars that related the levels in Drew's presentation. Okay? And also that Office of Biological Disenchantment. All right? Now, just to refresh people's memory from 2 days ago, we've seen so much. What was the function of the Office of Biological Disenchantment? It was where people were to send their failures. Something doesn't work, something's incompatible, something that gets the big red X. You send it to Drew, care of the Office of Biological Disenchantment, and the information is collated and gathered in a manner that allows the synthetic biology community to advance. We also recognize that the traditional way that companies do business is by keeping this sort of stuff as secret as possible. Why? You want your competitors to make as many of the same mistakes as you make, or preferably more. Indeed, companies have on occasion been known to suggest that things work that don't work in order to encourage their competitors to invest heavily in blind alleys. So we have a tradition of secrecy to make competitors eat cost, but what's being suggested within this community is the idea of sharing information on failure. And that data on failure and incompatibility and representations of it then get fed in other ways to make real those vertical green bars that sat in Drew's diagram. Those vertical green bars really talked about what you would do or have to do to be able to move from level to level. And in practical terms, about 80% of the green bars are protocols, technical standards, and conventions. Okay. Those technical standards and protocols allow you to take the parts and figure out what's going to work or not work as you assemble them, or to take the parts and assemble them into devices to systems. Now, protocols, technical standards, and conventions also occupy pride of place in intellectual property rights and knowledge-sharing world. How is this done? It's done very differently in Europe and the United States. If you turn to the United States, we have hundreds of private standard-setting bodies. The firemen, for example, go running around developing fire safety codes that define standards that they sell to municipalities and to contractors, protected by copyright. And they derive enormous revenues from the sale of their standards. One of the reasons why we in the United States have difficulty moving more to the National Institute of Standards is because of, let's call it, the understandable concern of these standard-setting private organizations to preserve their principal sources of revenue. That's one way of doing business. Open standards, rapid diffusion of heterogeneous standards, with oftentimes, but not always, de facto convergence to the standards of early movers. Now, that's the model that you're playing with in this field right now. What you want to do is get de facto standards out, keep them open, and hope that everyone converges to them. And the last approach, more in the European model, is governmental or intergovernmental standards, where you'll have national standard-setting bodies that then combine at the European level to create European standards, and then Europe's very good at organizing delegations that go off and dominate the ISO. This process tends to be a little bit slow, but negotiated common standards typically emerge, and those standards often fit European practice rather than American practice prior to common standardization. Now, why does this matter? It matters because one of the problems that you have right now is trying to create stronger incentives for participation in the standardized inventory of parts. Can the BioBricks Foundation sharpen incentives for participation? Okay. By creating a genuine BioBricks Foundation certified part, notice the little trademark sitting up there, in compliance with the BioBrick coupling standard 999, okay? Now, if you do this, the bad news is that you're starting to play the traditional game to a degree, but you're not behaving like those greedy private standard-setting organizations simply trying to accentuate or maximize revenue. You're potentially talking about using licensing to something precious, which is certification and standardization, and the trademark. To do what? Maybe you're limiting access to these benefits to those that share. And the Linux analogy is something that gets booted about a great deal. And it's not sing kumbaya. Guess what? This slide ended up getting shifted. What I'm going to do, okay. I'm going to actually not break out of PowerPoint mode. Too dangerous under these conditions. If you turn to Linux world, there's a bit of a myth that often circulates that what's going on is that people go open source and hold hands and sing kumbaya out of a spirit of solidarity and an aversion to the evil empire in Washington State. And there's a little bit of truth on that. But there are other motivations as well. When you go through, and this was a survey that was done by a German scholar, and you look to the motivations that people have for sharing, oftentimes the principal motivations, in fact, you'll find things like trying to spread costs or encourage harmonization to your standards or to spread development costs. But the number one reason why manufacturers reveal code is because the license requires it. Okay, if you go to David Letterman's top 10 list, good marketing is 10. But number one on the list is that the license requires it. And the question here would be, would there be means or methods of using a combination of licensing and copyright and trademark to try to, again, sharpen incentives for participation in the BioBricks Foundation without necessarily undercutting the spirit of that enterprise at all. Now, a final note on some hazards. There was a lot of discussion this morning on security concerns. And if you choose patenting as your approach to knowledge sharing and protection, have any of you seen a U.S. Patent and Trademark Office secrecy order before? How many of you have actually seen one of these things before? Okay. I will not ask you what it was that caused you to observe the secrecy order. I will tell you that the reason why I saw this was that a friend was working on a device. The device in question was something that he created not using classified information, not using publicly funded research. He was an ordinary schmo working for a European company in the United States, and he created something. He was dreaming of his retirement when he created this. So he sent off his application for the patent, and this is what he got back. And it says, well, this wasn't what he wanted to hear. Disclosure or publication of the subject matter by granting a patent would be detrimental to national security. This is not a good start. The subject matter or any material relevant to this application cannot be revealed or published or disclosed to anybody. You might note that this could have detrimental effects on commercial application. It gets a little worse. The principal must inform persons who know of the invention that they are bound by this secrecy order and by its penalties. That's why I know about it. You may notice that I am not telling you what the invention was because it's unclear about the extent to which I'm subject to the penalties. It's probably expired by now, and it's probably all right. The principal must not inform foreigners who know of the invention of the order, but must instead report disclosure to the U.S. Patent and Trademark Office. This creates a little awkwardness if you're working for a European company. The order does not mean the government is using or contemplating the use of the invention, and the principal may request compensation for non-use. Now, think about this for a second. You want to talk about catch-22? How do you go about calculating losses and litigating when you're not allowed to talk to anybody? You think Guantanamo's bad? This is the precedent. So what's the penalty? 2 years in federal prison, $10K fine. It's limited to what? Well, anything that is deemed to be a hazard by the Defense Threat Reduction Agency at this point. They're the screening agency. Who decides to impose the secrecy orders? Again, DITRA, but the Office of Naval Research actually was the outfit that nailed the unnamed inventor. How many patents are now covered? About 5,000. How many principals have been paid for non-use? About 5 of those 5,000, if the past is any guide. Now, I just mentioned this because if you go the patenting route, and if the security concerns that were being discussed this morning heat up, then this may be your fate and destiny. Instead, certainly go with other methods of protection and try to avoid this process if you possibly can. Or don't move into areas that would subject you to this level of scrutiny. A problem? The specific invention in question was one that is dual use with zillions of civilian applications, and I can think of one rather arcane military application, and it's a real one. And the invention in question could have done that arcane military application cheaply, but no better than widely distributed technology that pre-existed. Anyhow, the point here is that this kind of stuff has the effect of slowing down the diffusion of the fruits of innovation. Okay, a couple of final notes. There's an intellectual agenda ahead. Okay. There are a whole series of practical questions that I think we may want to be thinking about and exploring more carefully that would range from really simply gathering information on the state of play of a number of existing innovations from the MIT Commons through the Rockefeller Foundation contracts arguments, Okay, and that information needs to be pulled together. And I haven't done so, and it's something that I kind of recommend. A second point, we really need to do a systematic assessment of the strengths and weaknesses of the various basic modes of sharing and playing the property rights game, but in combination and not individually, and with reference to the specific items that we've been discussing as objects of potential protection. Now, there are some other issues that matter in terms of you as a community. You're talking now about near-term moves that may actually affect the long-term evolution of conventions that would be governing sharing of knowledge and the definition of property rights in this area. And we need to think through pretty carefully what the strategic implications of the early moves might be. Finally, and I put this one up there only half as a joke, okay, knock off a couple digits from the 100 million. But if you did have a private foundation that was offering money to further work in synthetic biology, well, are there investments on the intellectual property rights side that might be productive, as well as investments in the basic and applied research? You might want to, for example, use funding to clear title to bricks that are submitted to the inventory. There are a number of possibilities which haven't been much discussed that perhaps should be. The reason for putting up this slide with too many words, and there are about 10 other points, is that I genuinely applaud the points that have been raised, certainly by Rick, by all of you, as you don't simply go down the tried and true path. But there's a lot of work that needs to be done to be figuring out the implications of the choices and the possibilities. And I'm hoping that, and this is an ever-expanding ad hoc group, but I'm hoping that this ever-expanding ad hoc group might actually be able to tackle some of those issues and some of those questions. Thank you very much.
So that set the stage for the legal perspective, and Artie?
So I think I'm the only lawyer who's speaking at this conference, so I don't know what sort of obligations come with that, but fair warning, I guess, more than anything else. And the title is derived from the title on the conference agenda. However, I'll be ranging beyond these options, so its title is a little bit misleading as a consequence. So let me just start out by telling you that I think that this is really, really important stuff. A lot of the morning was devoted, the whole morning was devoted to issues of risk and security, and those are really important. But once you get past those, this is the roadblock or potential roadblock you're going to hit, and perhaps already are hitting. And you don't want to be where the software community is now, which is trying desperately to get Congress to pass legislation to reform the patent statute, and then being stymied in your efforts to lobby Congress by all the people who really like patents, for example. So a little foresight, if the software industry had had that foresight, I wouldn't have had to come here 2 weeks ago, as I came here 2 weeks ago, to help the software industry think of lobbying strategies in Congress. All right, with that introduction to sort of wake you up a little bit, because it is the last afternoon of the last day, what are some of the really dangerous patents out there, and why do they exist? Well, they exist because synthetic biology is at this perfect confluence of bad biotech patent law and bad software/information patent law, a perfect storm, if you will. Biotech-type patents at this infamous Court of Appeals for the Federal Circuit, which we, in our wisdom as U.S. Policymakers, decided we'd need a specialized patent court, decided to set it up in 1982, suffer from a very low so-called non-obviousness standard. In other words, almost anything that is even marginally novel can be patented in biotech. The flip side, which helps a little bit, is the patents in biotech are often narrow. The Federal Circuit, in its wisdom, sees biotech as being exactly like chemistry, and therefore, since chemical patents need to be narrow, biotech patents should be narrow. So in some respects, we only have an anti-commons in biotech, and I'm distinguishing anti-commons from patent thickets because anti-commons, that term I use to refer to situations where you have lots of patents, but they're all relatively narrow, so it would take money to invent around them, but it's conceivable to do that. And thus far, at least, biotech hasn't hit the wall that software has, simply because the patents are, for the most part, but see the recent case brought by Ariad against Eli Lilly, et cetera, on a very broad patent where they happened to win. For the most part, anyway, relatively narrow. Software, much worse. There's a low non-obviousness standard, basically because the PTO has yet to figure out what software really is. 15 years into software patents, they still haven't figured out what exactly software patents are, and so they don't know much about the prior art that would yield them to, that would cause them to reject patents. There's also a nice little thing that the Federal Circuit has put in, which says that in many cases, if you're talking about determining or arguing that a patent is invalid or obvious, there has to be a written document identifying every piece of information that a person in that area of the art would have known. And so if it's just general knowledge, for example, that's not enough. There's got to be a written document, which can have a really deleterious effect on software in particular, because lots of things aren't written down in software. So what we have in software, and hence my software in agony assertion, is broad patents and thickets. Broad overlapping patents, difficult to invent around, and as I'll talk about a little more in a moment, lots of patent trolls. So the most problematic synthetic biology patents, I suspect, are going to be those that look like software. They're going to probably be on parts, devices, and systems. Not all system patents are necessarily going to be problematic to the extent that, for example, Professor Kiesling's patent is a patent on a system that doesn't necessarily look much like software. But software patents that look like software, syn bio patents that look like software are going to be problematic. Particularly, I would argue, patents on parts, small components that use so-called comprising language. I don't want to make this into a patent law seminar, but comprising language basically means that you can encompass anything that includes the part plus. So if you have part A, then you encompass anything that would include part A, working up the levels of abstraction all the way to systems. And then you have the anti-commons patents, problems with biotech-like patents, but I'll focus on the thicket problems, which I think are the ones that are caused by software-type patents. Now, this is the so-called Schneider patent, the HHS patent that Ken put up earlier. Two very broad claims to DNA-based devices in that patent, and since it uses comprising language, it would cover both the device and the system of which the device was a part. The claims are to patenting DNA-based flip-flops, data storage devices, and patenting DNA-based gates. They start with NOR gates and basically anything that could be derived from a NOR gate. So a pretty broad patent, and my review of some of the patents that have arisen in this area makes it pretty clear that this patent is already being infringed quite a bit. Fortunately, thus far, there hasn't been any enforcement action brought, and I'll talk about enforcement in a moment and those issues, but this is a hugely important patent which is already being infringed. So evaluation, that leads to evaluation. It might well be valid because unless there was an explicit suggestion, a written suggestion in the prior art pre-1998 that DNA could be used for programming, that might be, that would be the only thing that would be sufficient to render it invalid. As I noted, it's potentially foundational patent for molecular computing in particular. And I think in some ways it compares to the patents on the transistor and the integrated circuit in the microelectronics industry. Those patents, as it turns out, were forced, the government forced the relevant players to license those patents because they were creating such a thicket in the industry. So arguably, if this is licensed improperly, it could be similar to the types of patents that we were talking about that were held by AT&T and Fairchild Semiconductors and Texas Instruments before they were forced into cross-licensing. How necessary will it be for digital control of gene expression? This is another thing that the patent talks about, that it could be used for digital control of gene expression. That's a subject I'm not particularly qualified to talk about, but it does seem to suggest that that's what it's going to cover as well, in addition to molecular computing. And as I suggested, we're really beginning to see the beginnings of patent thicket with this particular patent. There's an MIT patent on DNA binding proteins that I say probably infringes because I don't want to give legal advice, but almost certainly infringes. Then there are also pure software simulation patents. This is a Stanford patent on a system and method for simulating operation of biochemical systems. It's a very broad patent, perhaps invalid even under the very liberal standards for software, which allows very broad patents. How much infringement of this is likely, again, I can't comment, but my thought would be that it could be infringed by a lot of simulations of biological systems. Then there are also some narrower patents on a suite of patents on gene regulation systems. Now, these patents are narrower, and I think as a consequence probably at most pose a potential for an anti-commons problem. They overlap with each other, and somewhat interesting, none of them cites or actually these particular patents do cite each other because they're held by some of the same folks, but there is a potential for anti-commons created by these patents, but it's better than it could be because at least they're relatively narrow in scope. And part of the reason that, and they'll come back to this later, part of the reason that they're relatively narrow in scope is there's great prior art out there, what lawyers call prior art, on oscillators. The Elowitz and Liebler paper from Nature 2000 creates an oscillator that makes it very hard to claim oscillators broadly. So that's one strategy that can be used in thinking about how to defeat very broad patents. There are also protein and DNA patents. These are the most biotech-like patents, fairly narrow in scope, probably creating anti-commons problems, overlapping with each other. Again, anti-commons is probably not as bad because if you spend enough time and energy, you can invent around, but it does create create problems in terms of spending the money to invent around. Ownership and licensing, I mentioned this as a critical issue because, of course, patents themselves don't mean anything. It's all about the ownership and licensing. Interestingly, many of the patents, both the broad patents, the broad software-like patents, and the narrower, more biotech-like patents are owned by universities, and universities don't usually assert patents against researchers. There's also, there are lots of hortatory guidelines from the National Institutes of Health on not using patenting inappropriately, or at least if you do patent, try to license non-exclusively and so forth and so on, and universities sometimes adhere to those guidelines, sometimes not. They're largely hortatory because NIH is constrained by Bayh-Dole. And unfortunately, we see some examples of arguable troll-like behavior by universities. The NF-kappa B cell signaling patent, which covers any molecule compound that would modulate the NF-kappa B cell signaling pathway, was asserted by Eli Lilly, and it's probably going to be asserted against lots of other biotech and pharmaceutical companies by inter alia, Harvard and MIT. So legal technologies to combat what I think is the most critical problem. Anti-commons is a problem, but I think the foundational patent thicket problem, which is where software is now, is the critical problem. So there's the public domain strategy, which relies largely on norms, i.e. researchers put their stuff out there without seeking additional patents on them. There's a more aggressive strategy relying on commons of various flavors. This is the open source strategy that is often mooted. There's the possibility of pools, and then there's a strategy, which I think, as I'll talk about, is not a good idea, of mutual assured destruction, which software thought it could rely upon. Now it's realized it can't rely upon mutual assured destruction. Okay, so the public domain. I've had a lot of experience with this strategy because I've done a lot of work with NIH in its various efforts to use this strategy to basically defeat anti-commons problems, because this is more biotech-based, where you don't normally have very broad patents. And the idea is to put the information out there, have the prior art, render patents obvious. How well has it worked? Well, it appears that at least 20% of the genome is patented, probably a lot more. Whether those patents are valid is another question. So I think the verdict on that strategy is not in quite yet. But it is interesting that in addition to NIH using this strategy, private sector players in the context of the SNP consortium, the HGB stands for the Human Genome Project, which is NIH's project. The SNP consortium was a private effort by pharmaceutical companies relating to something that Rick said earlier about the interests of private industry. Sometimes private industry is quite interested in having all the information out there, the basic infrastructural information. And that's what the SNP consortium was. It was a consortium of 10 pharmaceutical companies that put all the information out there in order to defeat patents that would have created anti-commons problems. So a common strategy is more aggressive because it doesn't, for example, it is fearful of the public domain strategy. The public domain strategy sometimes allows so-called parasitic patents. The public domain strategy doesn't require that those who work on the public domain information contribute back. And that's what the common strategy is about. It is used in so-called viral open source projects to force people to put back improvements into the commons. And it may be particularly important to prevent hijacking of parts or devices of systems that could become standards, and hence the Linux effort to use a viral strategy. However, and this is in part to Ken's point about using this strategy, you do need an underlying property right, and it would be difficult, it's going to be difficult to secure copyright, I think, in many of the things, any of the parts, for example, that might be otherwise good candidates for a viral strategy. In the context of the HapMap project, which was mentioned earlier this morning, I have another perspective on the risks associated with the HapMap project, but for present purposes, the IP strategy they used is interesting because there was no underlying property right in the data, and in general, there's no property right in data. They had to use this very restrictive licensing strategy, which disallowed publication in open access venues, and I think that's a really cautionary tale. You don't want to use, it seems to me, viral strategies that disallow publication in conventional venues. Using the patent as a property right can be very expensive. There's a group called the BIOS project down in Australia that's using this, the patent as the underlying property right for their viral strategy. This is for transgenic plants. But there we're talking about just a few key patents that are the subject of the viral strategy. In the case of the parts that we're talking about here, you probably need more than just a few patents, and at $25K a patent, that gets pretty expensive. I've talked about or mentioned the idea that copyright probably doesn't attach to most forms of parts that are currently being produced. Copyright protects only expression, and even software, which is copyrighted, hence the ability of Linux to do what it does. The copyright protection is pretty thin. Now, it's possible that in the future, as we get DNA sequences that don't use the existing genetic code, that use codons not found in nature and amino acids either not used in the current system or not found in nature, those could be copyrightable, but anything that uses the existing genetic code, it seems to me, it would be difficult to make a copyright claim for it. Another strategy is pools. In the electronics industry, pools have been very, very prominent. They're particularly useful for standards because you want to make sure all your rights are cleared before you adopt a standard, obviously. High transaction costs associated with pools. You've got to get a lot of lawyers to the table, and you know how much lawyers cost. So how well will this work in SynBio? You know, it's difficult to know because in addition to getting all the relevant parties to the table, you have to know who all the relevant parties are. And there's always the lurking problem of patent trolls who have undisclosed patents. Either they're at the table and they don't disclose their patents, or they're not at the table. So these are very high transaction cost entities to come up with, these pools that can form around so as to clear patent rights on standards in particular. And then there's the strategy that of mutual assured destruction, which is what software adopted or continues to engage, and it hasn't worked particularly well. It's subject to the problem of trolling, and as a consequence, the software industry is now heavily invested in trying to change the substantive law of patenting, which it's very difficult to do, and it doesn't particularly deal with the standards issues either. This mutual assured destruction strategy, just to be clear, is the idea that I have 1,000 patents, you have 1,000 patents, we all infringe each other, and if we sued each other, we'd beat ourselves into oblivion, therefore we should just refrain from asserting our patents. If a troll comes in, they don't have to worry that their business model is going to be undermined because they don't have a business model, hence mutual assured destruction is subject to trolling. So where to go? Well, it seems to me the public domain strategy, which is thus far the strategy it appears that BioBricks has been pursuing, is a very valuable strategy, and I suspect some of these patents that are out there, even some of the patents, the most dangerous patents that I've mentioned, might be invalid given what's already in the public domain, although there are problems with looking at what was in the public domain as of 1998. Copyright in certain cases could be a valuable strategy, particularly when you're talking about parts that have become standards, and ideally copyright could be used in certain cases. Pools would be another strategy, again, high transaction costs associated with setting up pools, however. And then there's a general consideration we have to keep in mind. Although many of us make analogies to software and microelectronics, what we're talking about with synthetic biology is not necessarily the same economic model as microelectronics, and particularly not software, because at the end of some of these chains of innovation that we're talking about in synthetic biology will be stuff that we really want to be patentable. And so to have really robust viral licensing that might undermine patents on, for example, small molecule compounds would be a real danger. There's no comparable danger in software because nobody has ever shown, to my satisfaction, and I think to anyone's satisfaction, that patents have been important for software development. So with that, I will conclude, and I hope I came in time.
We have a few minutes left for discussion. I got a quick one for Artie. On the microelectronics side, you know, we've never used viral stuff. Software has, but in microelectronics we never did that. We just copyrighted things and then let everybody use it, but it wasn't viral anyway. And you know, companies like Intel make a lot of money on the fact that they can build a Pentium and protect a lot of the IP in there, while at the same time depending on a very open set of components that they get to build with. I mean, isn't that kind of similar to what you're talking about in terms of bio?
Yeah, I mean, I should let my prejudices be known. I really do like the idea of having a public domain component, an infrastructure that is in the public domain, and then having property rights on top of that infrastructure, for the most part, because I think viral licensing can get quite dangerous in areas outside of software. Having said that, I can see that there are dangers associated with the possible hijacking of standards that aren't that are purely in the public domain, because if you make improvements to the standard and take it proprietary, then the public domain, that option has been rendered less than optimal, because the proprietary standard will probably be better and win out.
So the way we used to do it was not to use the public domain, but to give worldwide, royalty-free, non-exclusive licenses. So to sort of define ownership well, but to make it broadly open. That was the kind of the way we did it, you know, 20 years ago. And that seemed to work okay.
Well, that's certainly another strategy that might work, but still probably more at the infrastructure level.
Yeah, the component level.
Yeah, the component level. Exactly.
Systems. Yeah. Question over here.
For you, I guess this is a very naive question, but whom do you commend to our attention who's capable of working this problem and solving it?
That's a good question.
You've identified the issues that everybody who's thought about it has identified, so we can be pretty clear that there's consensus on those. So, and further, you've made the important point, I think, that microelectronics is not exactly equal to biology. This morning, to mention Natalie, we saw a bunch of students at MIT making an electrical device based on a biological circuit that was to be based on an electrical device. You know, what's the path from here?
Well, I mean, part of it will depend upon whether you think you have a community that would be subject to some sort of consensus-based approach. For example, I think that there was some reason to believe that things worked out reasonably well for the human genome community, although the verdict is still far from clear. Well, then, that's one. And then the other question is the extent to which you think that there are certain real potentials for standards wars. And if there are going to be potentials for standards wars, I suspect on those parts there should be some sort of viral licensing attached. Even though I don't much like viral licensing outside of software, there may be a need for it.
Other questions? Yep.
I did a very cursory experiment and concluded that I am not the only one in the room that has no idea what viral patenting is. So I wondered if you could explain that. And I think I know what a patent thicket is, but I'd like to hear you clarify that as well.
Sure. Or can you? Okay. So the idea with BIOS, for example, this is the Biological Innovation for an Open Society group out of Australia, is that they have a patent on a particular method of making transgenic plants. And what they do, and this is somewhat clever, and could be thought about as a way to reconcile the need for downstream patents with the fact you want the infrastructure protected. What they do is they say that improvements to the methodology have to be put back into the commons, excuse me. However, if you're going to make a particular product with the method, that can be propertized. So that's one way of doing the viral idea is basically to take a property right and use that property right as a way of pushing information back into the commons. And you can do that with copyright, you can do that with patent, you know, conceivably even with trademark, although trademark is a pretty weak property right.
Okay, just to push that one little step further, the idea is that you have a property right, whether it be patent or copyright or trademark, doesn't matter.
Yeah.
And the contract or the license that you're writing sets it up so that people who gain access to this valuable thing agree to do some things in exchange that go beyond the usual paying you money. Okay, and it's viral in the sense that you're trying to spread participation in a community of sharing, let's put it that way, so that if someone uses that which is protected by patent or copyright, okay, and they use it and come up with a tweak on it and an improvement on it, that improvement goes back into the commons. I don't know if that helps.
Can you back up again and say why that's not appropriate? Or
Well, we disagree. I actually am more favorable to it, I think, than Artie is.
Well, there are two reasons I think that I'm not as entirely enthused about it as some. The first is, in this particular industry, you have to do the viral licensing very carefully so as not to undermine patents that might be really necessary for development. And if you don't do, I think BIOS, for example, did a fairly good job of making it clear that only portions of their license were viral, other portions were not. The other reason for being a little bit wary is that this looks very much like something that is often condemned by antitrust authorities on the grounds of basically expanding the power of your property right beyond what you actually got, because you're saying essentially that because you want access to my property right, you're not only required to perhaps pay me or what have you, you're also required to do all this other stuff, like take your improvements and put them back into the commons. In the context, if a for-profit firm were to do it, we'd call that reach-through licensing, like I'm reaching through to your improvements on a particular invention. And that's considered deleterious to innovation because it reduces incentives to innovation, arguably, if somebody else has a claim on your improvements. So there's a lot of literature actually out there that talks about whether this is an antitrust problem or not. I think on balance it's probably, given our really, really weak antitrust laws, it's probably not.
We have antitrust laws in this country?
Yeah, well, we actually don't. So under current circumstances, since we don't really have antitrust law, it's not a problem. But the principles, there's a concern, and I think even Ken mentioned it, that, you know, I'll flatter myself by calling myself part of your community, we are using it for good reasons, but the same principles can be applied for nefarious reasons as well. So what's good for the goose is also good for the gander, and you can't really parse the good from the evil users of this strategy necessarily.
But if you look to differences between the US and Europe on, for example, how antitrust is interpreted, the European Union is now playing with a very interesting concept where you allow some things to go forward if there are benefits, societal or benefits related to the consumer, that you would otherwise kill. And so if you take that principle of law from Europe and regard it as something worth playing with a little bit, what we're talking about here is something that would be similar to the application of that principle. It would be for greater good. It would have the effect in this instance of promoting progress, although our courts are not set up to interpret law in quite this way.
Yep.
I'm Jeff Way from EMD Lexogen Research Center, and our parent company is Merck KGaA, which the patent people are nodding about because we recently won a Supreme Court case that covers pharmaceuticals. And the good news is that this case, Merck versus Integra, had a very liberating effect on development of pharmaceuticals. And basically, if the implication of this case, I think, for synthetic biologists is that if you really are hardcore about the synthetic biology paradigm and you design something that you think might become a pharmaceutical, then you are allowed to test that preclinically. Before you go into clinical trials, you are allowed to do concrete tests to test your specifically constructed entity, and you don't have to worry about charges of patent infringement. And then also, as is the clear law, you can go into clinical trials and not worry about charges of patent infringement. And basically, you don't need to worry about charges of patent infringement until you actually start selling a product. So the point is, if you're developing pharmaceuticals, if you were in the pharmaceutical area, you can feel very liberated by this decision and basically not have to give yourself a headache about all of this. And you could tell me if that interpretation is generally shared, maybe.
Yeah, I would perhaps not be as, my interpretation wouldn't be as robust as yours of that particular case. As you might, I'm sure you know, since you were a party to the case, the case is somewhat internally incoherent because on the one hand it says what you say, but then it has a footnote 7 that says, but of course we're not calling into question patents on research tools. So Scalia, unfortunately, like many members of our judiciary, doesn't really know a lot about patents, and in general, I think the case will be subject to a lot of interpretation in the lower courts.
Right. I think there may be a gray area if you're doing something like constructing libraries where you don't have a defined therapeutic in mind, and that may infringe patents. But once you have a defined therapeutic, yeah, then you're pretty safe, at least conceptually when you have it. You can have a half a dozen or maybe even 100 defined therapeutics, and where the cutoff is maybe a little bit gray. But if you have things that you really know that you want to test, even if only one of them survives to go into clinical trials, you can feel pretty safe about testing those.
Although ironically, the more downstream you are, the safer you can feel. Whereas if you're doing purely, you know, research with no particular end in mind, you're not safe at all. Yeah. So,
question.
University of Hawaii, to expand the legal lexicon of the uninitiated to the megafauna. Can you explain what trolling means? Oh my goodness! Yeah, this. I'm sorry. I guess like. Well, kind of like that. It actually, you know about trolls, the trolls who charge a tax when you they pop up when you pass over a bridge and charge you. It's a similar concept. You've built something, you've spent a lot of money, you know, invested a lot of money in the the BlackBerry. Oh yeah, there we go. So how many of you are familiar with the BlackBerry case? A few people. Yeah. So in that case, arguably, the entity that was trying to shut BlackBerry down was a troll. BlackBerry had built this fabulous device, and NTP, which is a patent holding company, said, we have this patent that we think covers your device, and we're going to shut you down unless you pay us a huge amount of money. And BlackBerry caved and gave him $612 million? Yeah, $612 million.
Yeah. In part because the uncertainty over the claim would have killed them.
And that's the problem with software claims. They're just so broad and vague, and that's, I mean, I fear this synthetic biology is heading into software land.
Stick with microelectronics, it's much safer.
Exactly.
Okay, with that, I think we'll close this session. I'd like to thank our panelists. And next session is the community organization session, and it's going to be moderated by my good friend and colleague, Tom Khalil. Tom is the special assistant to our chancellor at Berkeley for Science and Technology. Tom.